Okay, so here's a simple example. This is a parabola, and the equation is simply y equals x squared. And just to review our terminology or definitions, dy dx equals the instantaneous rate of change at any point on this curve. And we also call that f prime of x typically. And so there is a formula for dy dx, a general formula for dy dx of a parabola like this. And let me just show you what it is. Dy dx equals, again, just another name for the same thing, f prime of x equals 2x. Well, again, the key is, how do you get from x squared to 2x? And the theory behind that, or the justification behind that, is the theory of derivatives, which again you can find on page 740. But you don't have to memorize the theory because there's sort of a simple set of rules. In this case, you look for the exponent, it's 2, and you take that 2 and you move it down and make it a coefficient of x. And then the exponent, there's still an exponent there, more or less, theoretically at least, but it's going to be 2 minus 1 equals 1. So the derivative, f prime of x, dy over dx, equals 2x to the first power, which of course is just 2x. So what does that mean? Again, this is a function of x. But if you plug in various values for x, you get the tangent line, the rate of change at a particular point. So what's the tangent line here at x equals 0? Well, it's a horizontal line. So if x equals 0, then 2x equals 0. So the slope of this line is 0. That's the rate of change, 0. This is also known as a minimum, which you're familiar with. And the rate of change at a minimum or a maximum is always 0. But of course, the dy dx changes depending on where you are along the curve, right? These are all different these are all tangent lines with different slopes. So but you would just plug in. So if you want to find the slope at x equals 1, well, that would be 2x equals 2. At x equals 4, 2x equals 8. So that's a simple example of how you find the derivative. Let me show you one more video, and I'll show you the more general rule.